Hello and welcome back to Apt for You. In this particular video, we'll be discussing a new series on dynamic programming. So, as I had already discussed, that every day we'll be picking up problems from different topics of data structures and algorithms. So today I'll be just picking a problem from dynamic programming, and a very standard and classical problem from dynamic programming, which states that we have to find the minimum number of coins that is required to basically amount to a specific amount. In the sense, suppose we have coins of denomination 1 available, coins of denomination 2, and coins of denomination 5 available. So basically these are the three denominations available, which means that suppose the bank basically produces coin of value 1, coin of value 2, coin of value 5, right? And a person basically wants an amount of 11, and he wants to keep that amount in his pocket. So basically he would prefer to keep as minimum number of coins possible, that amount to rupees 15, that amounts to rupees 11, right? So basically you know that there are 1 rupee coins, there are 2 rupee coins, and there are 5 rupee coins, right? Infinite amount, infinite numbers, right? Infinite numbers means there is no limit to how many 1 rupee coins are there in the bank, right? There is no limit to how many 2 rupees coins are in the bank, and there is no limit to how many 5 rupee coins are in the bank, right? And now you just requested that I want an amount of 11, and you know that you want to keep as minimum coins as possible, but it should amount to 11. So what is the approach to it? Now definitely right now, since 11 is a very small value, you can just say that okay, the very best thing is pick as large amount as possible. So basically I will pick up 5, one coin of 5. So you can still pick one more coin of 5, right? So I'll pick one more coin of 5. As I said, this is infinite available, infinite instances of this particular coins are available. Now I need 1 more rupee, and then basically you know that 1 rupee denomination is also available. So basically you can pick 1 rupee. What is the amount is equal to rupees 11, right? So basically you can see that with only 3 coins you can basically reach amount 11. Other option was you pick up coin 1 rupees and you keep on picking 1 rupee coin, right, 11 times. So basically that also you will be having 11 coins amounting to 11 rupees, right? What if I say about 2 rupee coins? Then definitely that is also possible. You will pick 2 rupee coins how many times? 5 times, right? 3, 4, 5 to the 10 plus 1 rupee coin once. So you will basically pick 6 coins to amount to rupees 11. Here you are picking up 11 coins to amount to rupees 11, and here you are picking only 3 coins to amount to rupees 11. So which is the basically you would prefer? I would definitely prefer keeping as least coin as possible, right? So I would picking up 3 coins only, because this amount 11 can be generated by using 3 coins at minimum, right? So this is how we have to, this is what we have basically have to do with this particular problem. Given an amount and given some denominations that are available, you have to find out what is the minimum number of coins that will be needed to generate that particular amount, right? So we are going to take the help of dynamic programming to solve this particular problem, right? I hope you are already familiar with what the problem actually is, this minimum coin, a very common problem that is discussed. I'll basically focus on the way the solution actually works, right? How dynamic programming will actually help us to solve this particular problem. So we know that dynamic programming basically uses optimal substructure property and overlapping subproblems property, right? So we will try to exploit that particular aspect of dynamic programming. What we will do is, we know that we have an array nums. Now what is nums? Nums will basically store the different denominations available. So basically nums is an array that stores the different denominations available. So the elements are 1, 2 and 5. This is the element of this array nums. Getting the point? These are the elements of the array num. These are the index 0, 1, 2, and the elements of this array num is basically nothing but the denomination that is available. 1 rupee coin available, 2 rupee coin available, 5 rupee coin available. What is the amount? Amount is basically the target. The target, that is how much money do you actually want, right? Based on that only I will be generating the coins. So that particular value is basically the amount. How to solve this particular problem, minimum coin, using dynamic programming? As I said, we will be exploiting the memoization property, okay, that is available under dynamic programming, and we will try to solve the sub problems, smaller problems, and then we'll end up to the larger problem. Let us see how it will actually work. So first of all, I need to create a table. I will be taking the help of a table. Now how will the table look like? So basically this is the table, right? So what is happening is, let me draw it properly. So what happens in the table is you have elements from 0. You start with 0. Okay, let me erase this also. Let me first of all write this. So we will be starting with 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. Why did I do so? I'll explain you. So basically we are trying to divide the big problem into smaller problems, right? So this is the thing, but my amount, right? So amount. So since I want 11 rupees, so I'll be just writing all the values from 0 till 11, right? Why am I doing so? You will see while we will discussing the approach of solving this particular problem. How is it actually solving? Fine. So, and another thing is basically again we need to write from 0. Now how many elements are this in this array? There are 3 elements in the array, right? 3 elements in the array. So these 3 elements will also be there, plus we will have an element 0, right? So 0, index 1, 2 and 3. So they basically, you see these 3 values, these 3 corresponds to the index of these 3 elements, right? These 3 elements, right? If you see 1 minus 0, 1 minus 1 is equal to 0, which will point to this element. 2 minus 1, this is the index, okay? 2 minus 1 is equal to 1, which will point to this index, this element. 3 minus 1 is equal to 2, which will point to index 2, which is 5. Getting the point? So this way we will basically keep track of the array also, this array, nums array. So 0, 1, 2, 3. Remember, this is nothing but the index values, right? So amount here and the nums that we are using is vertically downwards, right? Fine. So now let us work on our problem. How will the problem actually work? So let us first quickly draw the table. So I am just drawing lines and creating a table, and we will understand how it will actually work. Great. So let me just draw the lines here also. Cool. So now we have this. Remember, this drawing the table is very helpful, okay, in solving the particular problems, because this will actually help you to visualize what is actually happening, right? And dynamic programming strictly basically uses this particular technique, right? This is very helpful in dynamic programming when we basically solve the sub problems, store their result in the table, and then use it in future. So what is happening? We are just keeping on drawing the tables. So let us complete this first. I'm sorry, I should have paused the video, right, for this, but anyway, it's fine. Okay. So now what should we do? Now we know that our table is ready. Table is ready. Now how should we read it actually? So basically we will use two variables, I and j, right? We will use two variables, I and j. Now we know that this particular values are nothing but amounts, right? I have written here amount, and the value downwards are nothing but the denominations, nums, right? So we will use a variable I to traverse downward. A variable I will be used to traverse downward, and a variable j will be used to traverse rightwards, right? A pointer I will be basically traversing downwards, and a pointer j will be traversing left to right. So whatever we have done so far, let us code that particular thing, whatever we have done so far. So what have we done so far? So far we are declaring two variables, integer I comma j. Fine. We are creating this table, right? So we are creating this table. Let us create a table dp. And what would be the size of this dp? The size of this dp will be nothing but equal to the total denominations. That is, how many total denominations were there? You see, the question gives the denominations in the array nums, right? So basically let me use one more variable n, okay, and I will store the size of this particular array nums in this. So n equal to nums dot size. So what will happen? The size of this particular array is nothing but 3. So n will be equal to 3, right? And we will be making a table of size n plus 1. Why n plus 1? You see, we have 3 elements in this array. We have only 3 elements in this array, and 3 elements in the sense only 3 denominations. but we are creating space for 4 denominations, right, where this will point to this particular position, this will point to this position, and this particular index is pointing to this position, right, and we will have one more for 0. We will understand the importance of 0. This is a very basic base condition, right. So for this also we will need one more space. So basically we will assume that the size of the nums array is nums plus 1. Okay, so n plus 1 done. Now similarly we have in the if you see the vertical columns, right, vertical columns, how many columns we have? Columns is equal to total amount, right. You will write amount is 11, right. You see amount is equal to 11. So I said you that we will be creating columns from 0 till 11, where 0 will be used for solving the base condition, right. So we will be having one more column here, sorry, yeah, this is fine. So see, 0 till 11 we have basically 11 columns from here to here, plus this column 12 columns. So basically the total number of columns will also be amount plus 1. So we are using this table to basically solve this particular problem. Now how will this table be helpful? So that is basically where dynamic program will come into action. Now you see, just reply to my questions, right, and that will be enough to understand this. So if you just keep on replying my questions, you will be understanding how it is actually working. So let me just change the color of this ink to green. Green seems fine. Yeah. So the first question is, remember dp of ij, what does it mean? Dp of ij, whenever I say point to dp of ij, we know that I is basically this row, so I will write it here. I is equal to row number and j is equal to column number, right. I is equal to row number, j is equal to column number. Now if I say dp of ij, I basically am pointing to ith row and jth column, ith row and jth column. So what about this particular value? What should be here? These values basically indicate the minimum number of coins required, right. Minimum number of coins of denomination I required to successfully get the amount j. Remember this, okay. So basically we are finding minimum coins required to get amount j, okay. Minimum coins required, and what will be the denomination? So basically minimum coins of denomination, basically 0 to I. In the point, whenever I say dp of I, it indicates that you can take all those elements till that particular, all those denominations till that particular value, right. Which simply indicates that, suppose I say dp of 0 comma 0, what does it indicate? Then this position. Now this position basically indicates that how many, if my target amount is 0, this is my target amount, right now j is here, which says that how many 0 denomination coins you want to get the amount 0. This is the question you have to ask yourself, the very sub problem, very base condition. How many 0 denomination coins basically you want to get an amount 0? What is the answer? The answer to this question is 0, right? Because if I want 0 rupees, if I want just 0 rupees, I don't want any rupees actually. The best thing available is basically not picking any coin, right? So 0. Minimum coins required is 0. If you want 0 rupees, so basically you should not pick up any coins. So 0 is the value that will be filled here. What is the next thing? The next thing is, we will come to this particular row, this particular cell. Now if you come to this particular cell, what is the question you need to ask yourself? The question that you need to ask yourself is, I need, now this j pointer will basically move right. J pointer will basically move right. Now here you will be asking yourself, what is the minimum number of coins of denomination 0 required to get the amount 1? Now say, you want an amount 1, right? You want an amount 1. Now what is the minimum number of coins of denomination 0 required? So basically 0 denomination coins. Can you imagine? This is not going to add any value, isn't it? So, and we know that infinite number of these coins are available. So basically infinite, right? This will not, you will not be able to reach this amount, right? You will not be able to get a value 1 using 0 coins, using 0 denomination coins, 0 value coins, right? Because the value will never add up to 1, right? Because the value of that particular coin is 0, so infinite. Similarly, if now j comes here and I ask you how many 0 denomination coins required to get the amount 2, so you need amount 2 and you have 0 denomination coins, right? Only 0 denomination coins, because I is here right now. I is pointing to this particular position, right? Remember, we are calculating for all the values of j for each value of I. Right now I is here and j is keeping on traversing, so I is here. In the I is here, it indicates that you are allowed to take only this denomination coin, 0 denomination coin, right? So again, with 0 denomination coin you will not be able to receive any values, so I am just putting there infinity, because you will never be able to meet that particular amount with 0 denomination coin. Next time I increases to the next row. Now 1 indicates that you can now take values or denominations that are permissible. The denominations that are permissible are the first value in this array. Now this 1 is actually not indicating to this particular value. Right now this 1 is indicating to the first index position, right? That is 1 minus 1. Remember I said you 1 minus 1 is equal to 0, index 0. So index 0, what denomination is there? Index 0, this denomination is there, which indicates now you are allowed to take 1 as well as 0 denomination, right? So now if I ask you, when I is pointing to this particular row 1, it indicates that allowable denominations are, so you just write here, sorry, yeah, you just write here allowable denominations, right? So what is the allowable denominations now? Since I is pointing to this index position, value 1, this row 1 indicates we should point to 1 minus 1 index of nums array. So 1 minus 1 index of num array is equal to index 0, and index 0 value is 1. So basically allowable denominations are 1, right, and obviously 0, right? So now if I ask you, you need to produce 0 rupees and you have infinite number of denominations of 1 and denomination 0 available. So how many coins minimum would you require? Now we will already know the base condition. If I need 0 rupees, then whatever, despite of the amount of denominations you have, you will always require 0 of that, right? Isn't it? This is the base condition, because I don't want any amount. 0 indicates what? You don't want any amount. 0 indicates you don't want any amount. So since 0 indicates I don't want any amount, so basically it will indicate that whatever be the denominations that are allowed, right, the best thing is not to pick any coin. So 0 coins will be used to make rupees 0. Now if I ask you, now you see this, for each value of I, when initially I was here, so I traversed the entire value cell j and I filled infinity. Now again I will come to the next row and j will again start from here. So initially j was here, I filled it 0, j now moves to the second row, second column. So now we are focusing on to getting the amount 1. Remember, this is the amount column. So I want to get rupees 1. So in order to get rupees 1, right now the allowable denominations are 0 and 1. So minimum number of coins that you require will be how much? Obviously 1, right? The minimum number of coins that you require right now will be how will you decide it? So for deciding it, like right now you want to basically produce the amount 1 and the allowable denominations are 0 and 1. So what will I do is, basically you have two options. Either you pick up 1. So if you pick up 1, how many coins do you require? 1. Or if you don't use 1 rupee coins, then how many 0 rupees coins would you require to fill this particular value 1? So basically right now, if we want to fill this particular cell, okay, we want to fill this particular cell. In order to fill this particular cell, you will check what are the allowable denominations. So allowable denominations are 0 and 1, right? Because 1 is basically this one. So now we will see that I have two options. Either I can use the denomination coin 1 or I cannot use the denomination coin 1. Suppose if I use the denomination 1, then basically you can use only 1 coins to get the value 1. But if I say I will not be using this denomination, that is if I am going to use only 0 denomination to get 1 rupees. So 0 denomination to get 1 rupee, how many was required? Infinite. Compare these two. What is the minimum? Minimum is 1. So basically the value here that you will be filling is 1. Getting the point? So I hope you are getting the point how we are actually calculating the minimum coins required. You have two options. Either you can pick the denomination or you cannot pick the denomination. If you reject the denomination, then see how many basically coins was being required earlier. If you pick up the denomination, then you see how many coins is being required, right? Now basically come here. Now J will come here. Basically, you want to produce 2 rupees. Okay, you want to produce 2 rupees, and the available coins are basically how much? You want to produce 2 rupees, and the available coins are basically 0 and 1, right? So here it is 0 and 1. So what is written here? 0 and 1. So basically you can use denomination 0, you can use denomination 1. Now how should I fill this? So basically right now you are in this particular row. This particular row indicates value 1. Value 1 indicates 1 minus 1th of this array. This array, right? 1 minus 1 means you are allowed to use only this rupees coin, 1 rupee and the 0. So now if I pick up this particular, if I now add this particular cell, for filling up this particular cell, what we can do? We can pick up the value 1. I can pick up the value 1, right? If I pick up the value 1, okay, if I pick up the value 1, suppose I don't pick up the value 1, okay, we have two options, isn't it? Because we want to basically get an amount of 2 using the denominations 0 and 1. So suppose I don't pick up value 1. So if you don't pick up value 1, how many 0 rupees coins will be required to fill up 2? So 0 rupees coins to required to fill up 2 is equal to infinity, comma. Now if I am going to use 1 rupee coin for getting 2, so first of all you will pick up 1, you got 1 rupees, right? And again next time again you will be picking 1, 2 rupees, achieved. How many coins was required? 2 coins was required. So infinity comma 2, which is the minimum? Basically 2 is the minimum, so the minimum value will be picked and stored here, 2. Same case for 3. Option is you can use how many denominations? Now you see you are still in that row, you are still in this row. Value is 1. 1 indicates 1 minus 1 is equal to 0, 0 index, that is of nums, that is 1 rupee. You can use only 1 rupee denomination and the 0 value. So basically what happens here is, now you want to use 1 rupee coin to produce 3 rupees. Okay, now what are the available denominations? You can use 0 rupee coin, you can use 1 rupee coin. If I say at the first time that I don't want to use 1 rupee coin, then how many 0 rupee coins would be required to produce 3? You will refer to this cell. 0 rupee coins required to produce 3, infinite. Now suppose if I am going to use 1, then I'll be using 1, again I'll be using 1, I'll be staying. Now you see how is this being calculated? So as I said you, if I am not going to use, we are going to use these two denominations. Suppose I say that I will not be using 1, then you will be checking how many 0 rupees coin will be required to produce 3. So you got infinity. Now coming to 1, now if you pick up 1, put in the bag, how many values now you left with? 2. Getting the point? You want to get the value 3. Right now I picked up 1, so I picked up 1, put it in the bag. Now you want to get value 2, and available denominations are 0 and 1. So you know that how many minimum coins are required to get the value 2. To get the value 2, how many minimum coins was required? Minimum coins required was 2, right? So you can directly say that 1 coin I have already picked up, and I know that for getting this 2 I need 2 coins. So 2 plus 1 is equal to 3. Getting the point? So I can directly fill 3 here. So did you understand that we are basically taking the help of the previously stored value to compute the current value, right? Got the point? Now let us move ahead. So basically right now we are still in this particular row. This particular row indicates value 1. Value 1 indicates, I equal to 1 indicates we are pointing to the I minus 1, that is 1 minus 1 equal to 0th index of this nums array, right? So let me write this array again clearly. Nums array has 1, 2, 5, right? So nums array basically has the values 1, 2 and 5. So nums array has value 1, 2 and 5. This is the index 0, index 1, index 2. So here I equal to 1 indicates, refer to the 1 minus 1, that is 1 minus 1, I minus 1, that is 1 minus 1 equal to 0 index, which means you can use this denomination or you can use no denomination, that is 0. And then you have to find the minimum coins required. So now if you say, now see how we are going to use this problem. Now suppose I ask you, you are in which row? We are in basically this row, and this row value is 1, indicates point to this denomination 1. So allowable denominations are 0 and 1. Fine. Now if I ask you, given these allowable denominations, you want to produce an amount 4. Okay, so minimum number of coins required is, So basically, since I can use 0 denomination or 1 denomination, what if I ignore 1 denomination? If I don't consider this denomination, then how many 0 coins will be required to produce 4? So 0 coins required to produce 4 is equal to infinity. Infinity. Too many, isn't it? Otherwise, next option is you pick up one coin. Okay, since you have 1 rupee coins also and you need 4 rupees. So first of all, I'll pick up 1 rupee coin. Right. Now how many rupees more I need? I need 3 rupees. So you need 3 rupees and you have the available denominations as 0, 1. How many coins were you requiring to generate 3 rupees? To generate 3 rupees, given that I have the denominations 0 and 1, minimum 3 coins was being required, right? So what will you do? 3 plus this one, 4. So likewise, this cell will be filled with these values. Getting the point? So you can see 1 rupee coins, how many required? Minimum 5, minimum 1 rupee coin 6 required, and so on. You can fill this. So this row is also complete. Now we will move to the next row. This J will again start from beginning. Okay. So I hope you are getting the intuition how it is actually working and how we are basically using this table to solve the overlapping to exploit the overlapping subproblem principle. So now when I is pointing to the next row, the available denomination is basically I is pointing to the next row, in the sense I is pointing to this row, right? I is pointing to this row, and in this particular row, what is the value of I? I is equal to 2, right? If I is equal to 2, we know that we should basically point to I minus 1 index of nums array. So I minus 1 is equal to 1 index 1. Index 1 is nothing but 2. So this indicates that allowable denominations are all the elements from starting till this index 2. 1, 2. 1, 2, all the elements from starting till this index 1, 2, right? Now you see, allowable denominations are 0 by taking no coins, or you take 1 rupee coin, or you take 2 rupee coins, because we know that index is pointing to this position. So basically we are allowed to take all the coins from this to these denominations. Fine. Now you see, for starting with the very first cell, so starting with this particular cell, again, you don't want any rupees. So the very minimum number of coins would be 0. By not taking any rupees, I will not give you any rupee coin. That is that my problem will be solved, isn't it? You want 0 rupees, so I will not give you any coin, and that means 0 is the minimum value for getting this particular condition. Now J comes here, I is still here. Okay, this is the new position of I. So this is basically helping us to know that what are the possible denominations. Now you see, you want to produce 1 rupee coin. What is the amount that you want to produce? Basically 1 rupee coin, right? So this has got a bit haphazard. Let me just clear it. Cool. So this is basically let me use the red pin. So 1, and this is basically 2. Fine. So the problem is, now for filling this particular cell, what is the problem? The problem is, this is a sub problem. Remember, we are talking about sub problems. We are using sub problems to solve the bigger problem. So the problem says that you want to get rupees 1. Now if you want to get rupees 1, what are the available denominations? These are the available denominations, right? If you want to get rupees 1, these are the available denominations. Now the denomination that you can use right now is this one, suppose 2, right? Because we are pointing to this one. So if this particular amount is 2 rupee coin, can you use 2 rupee coin to get 1 rupee coin? Definitely not, because this is too much, right? So if not, then what will we do? We will see for other options. Can we get rupees 1 using 0 and 1 rupee coins? Yes. And where is the answer to this available? Using 0, 1, using 0, 1 to get 1. Obviously you know the previous cell, this one, the cell right above it. This is the cell that will help you to get the answer. We have already calculated how many minimum 0 or 1 rupee denominations is used to get rupee 1. So the value is 1. So again 1 will be copied here. I hope you got the point, because we know that the value 2 basically is too high denomination, very large. We cannot use it. So basically ignore it. If we ignore this denomination, and basically we are considering that we have only 1 denomination and 0 denomination, and we know that the answer to that is already stored in this particular cell. We will refer to this cell and get the answer. We will code to that particular problem also, don't worry. Now let us come here. You want 2 rupee coins, so this is already filled, right? So you know that our denominations available for this particular row is 0, 1, 2, right? So 2 rupee. So if you talk about 2 rupees, so basically you want to get 2 rupees coins, and the available denominations are either you can use 0 denomination or 1 rupee denomination or 2 rupee denomination, right? So if I don't take 2 rupee coin, if I don't use 2 rupee coin, then how many coins will be required to produce 2? If you don't take 2 rupee coin, how many coins will be required to produce 2? So basically the problem reduces to, you have this denomination and you want 2 rupees. So the answer to this is present in this particular cell, remember? This particular cell. How many was required? 2 was required. So 2 required, comma. Now suppose I am using 2 rupees coin. If I use 2 rupee coin, then how many 2 rupee coin will be required? Basically you pick up 2 once. You just pick up 1 2 rupee coin and you see you reached up the amount. So basically what is the minimum of 2 and 1? The minimum of 2 comma 1 is equal to 1, which means that now you can use only 1 2 rupee coin to get the amount of 2, right? So you can use the amount of only 1 2 rupee coin to get the amount of 2. So this is also successfully filled. Now J comes here, basically J was here, now J comes here. 3 rupee. So you want to produce 3 rupees. How many 2 rupee coins? Now you see you want to produce 3 rupees. Now you are still in that row, right? You are still in this row. See, I am going very slow and in detail so that you can actually understand. I am not caring whether the video will be lengthy or not, but still I want you to understand it. 0 1 2, these are the available denominations. Why? Because I am in this row. Since I am in this row, the index is 2, pointing to 2 minus 1, which is equal to index 1 of this particular array. Index 1 particular of this array means you can use all the denominations from the beginning to here, and basically this is the largest denomination available. So now if you want 3 rupees, if you want to make 3 rupees and you have this denomination available right now, maximum 2. So if I take, suppose if I don't take this 2 rupee denomination, if I don't take this 2 rupee denomination, the problem reduces to using 0 1 to get 3 rupees. Now we have already discussed that how many 0 1 minimum will be required to get 3 rupees. The value is present in this cell. How much? 3 coins will be required to get 3 rupees. So we have one option, we can use 3 coins to get 3 rupees. Other option is don't ignore 2 rupee coins, include 2 rupee coin. So if I include 2 rupee coin, so this is my bag, I included 2 rupee coins. How many amount is left? 1 rupee, right? Because I had 3, I included 2, I have 1 left. Now can this 1 again be successfully achieved by picking up this particular 2 rupees coin? No, right? So what will we do? We will reduce the problem to using 0 and 1, you want to get 1 rupee coin. Where is the answer to this particular problem present? The answer to this particular problem is present in this particular cell, 1, right? In this particular cell, you want 1 rupees and you have 0 1 rupees, 0 and 1 denomination. So basically 1 coins. So you will pick up 1 coin. So you see, initially I picked up 1 2 rupee coins, and right now I am picking up 1 2 rupee coins. So basically total you have 2 coins required to get the sum equal to 3. 1 coin will be of 2 rupees and 1 coin will be of 1 rupees. Getting the point? So see how the sub problem, this was a sub problem, is basically used in the later stages to solve the bigger problem. Are you getting the point? This is the beauty of dynamic programming. This will actually help you to get the answers. Now I'll be slowly and steadily filling up all the details. Now you have 4 rupees. You are in this row still. This row indicates this position, means maximum denomination available is 2. So allowable denominations are basically 0 1 and 2, right? So I want the value 4. If you want the value 4, I have one option. I will not take this 2 rupee coin. If you don't take this 2 rupee coin, then allowable denominations are 0 1 to get 4 rupees. Where is the answer to this available? You can use only 0 and 1 to get 4. Basically in this row, previous row, 0 1 to get 4. So 4 coins. 4 coins were being used in that stage. But now I will basically, initially I am ignoring 2, but now don't think that I am ignoring 2. Suppose I am considering 2. Now since allowable denomination is 0 1 2, suppose I am not ignoring 2. If I take 2, then I want to get 4 rupees. I picked 1 2 rupee coin. Now value I want to get is 2. Now problem becomes, you want to get rupees 2 using 0 1 2. Using 0 1 2 denominations, you want to get rupees 2. What is the minimum number of coins required? So minimum number of coins required will be the answer to this particular cell, 0 1 2, and you want to get rupees 2. So 0 1 2 to get rupees 2 means in this particular cell, this particular row, I want to get value 2. Minimum minimum number of coins I was requiring is 1. Getting the point? Because 0 1 2 are the allowable denominations, means you are in this row only, right? And you want to get rupees 2. Minimum number of coins required is 1. So you will write 1. And we know that since initially I picked up 1 coin, so I will consider 1 from there. Total coins used is 2. So you can use only 2 coins to get the value 4. Getting the point? Very interesting and very easy to understand also, right? Okay, so what's happening? All right, consider 5. You are still in this row. Okay, remember this working is very easy, okay, to understand. Allowable denominations. You are still in this row, right? You are still in this row. Allowable denominations are, you know that in this particular row it is pointing to this index. Maximum denomination is 2, so maximum denomination is 2, right? So since I want the value 5, I have two options. Suppose I will not take 2, I will not pick up 2 rupees coins, then the problem reduces to using these two denomination to get 5. What is the answer to this present? Where is the answer to this present? Minimum number of 0 1 coins required to get 5. So basically in previous row, this position, that is 5. So one option you have, you can do that with 5 coins. Another option, suppose I pick up 2 rupee coins. Suppose I will pick up 2 rupees coin. Now if you pick up 2 rupee coins, then what will be the problem? The answer, now suppose if I am picking up 2 rupee coins, now problem becomes what? The problem is you can use these denominations to get 5. So what will I do? I'll initially pick up 2 rupee coins. So if you pick up 2 rupees coins, you inserted 1 2 rupee coin inside. What is the amount you need? You need basically 3 rupees now, using these 3 denominations. So now the problem reduces to 0 1 2 coins are available and I want rupees 3. Minimum number of coins needed is, do you think we have to compute it again? No, definitely not, because the answer to this is already available. You can use 0 1 2 denominations, which I am in this row, and I want amount 3. Amount 3 basically indicates this particular column. I had already calculated 2 coins is required. So basically to fill this task you can need 2 coins only, and I have already used 1 coin earlier, equal to 3 coins. So basically 3 coins you can require to get the value 5. Similarly, if you carry on, you will get that to get the value 6, okay, using these 3 denominations. Now let us fill very fast. Okay, I'll not take much time. So I hope you are understanding the working, how the subprobleming is being used. Now I'll be very fast. Since I'm in this row, 2 minus 1 is 1, pointing to this index, means maximum denomination you can use is 2. So basically 0 1 2, right? So means you can use this denomination here 2, and you can also use all denominations before. Now I want to get rupees 6, so I can basically use 3 coins, 2 plus 2 plus 2 to get 6. Similarly, minimum number of coins to get 7, I can use 2 plus 2 plus 2 plus 2, sorry, 2 plus 2 plus 2 plus 1, right? See, 4 coins to get 7 if I'm in this row, because you can use only these denominations 0 1 and 2. Similarly for 8, you can use 4 coins to get 8, 4 2 ja 8, 2 plus 2 plus 2 plus 2. For getting 9, you need 4 2 rupees coin plus 1 1 rupee coin. Then you can use only 5 coins, right, to get 9. For getting 10, you can use 5 2 rupee coins. For getting 11, you can use 5 10 2 rupee coin plus 1 1 rupee coin, 6 coins. Now come in this row. Similarly, if you come in this row, I'll be very fast now. Similarly, if you come in this row, you want to get 0 rupees. So basically, I'll not pick up any coin. If you want 1 rupees and you know that you are right now in this particular index 3 indicates 3 minus 1 2, pointing to this denomination 5, which means now you can use the denominations 0 1 2 and 5, all the denominations from here starting till here. So you can now use 0 1 2 and 5. So if all these are the available denominations, and we know that the denomination I am indicating to is now 5, can you pick up 1 5 rupee coin to fulfill 1? Definitely not. This is very high. So if this is too large denomination, what do? We look into the previous cell. Previous cell, how many minimum denominations was required? 1. So 1 is the answer. Similarly, if you are 1 to 2 rupees and your maximum denomination available is 5, will you use 5 rupee to get 2 rupee? No. Then the problem shifts to 0 1 2 to get 2 rupees. So you can use only 0 1 2 to get 2 rupees. Where should I point to? This particular row and this particular cell. Value is 1. Again you will be 1. Similarly, to get 3 rupees, can you use 5 rupee? So your available denomination is 0 1 2 5. Do you think you will be using 5 rupee to get 3 rupees? Definitely not. Remove this. The problem reduces to using these 3 denominations, that is the previous row, to get 3 rupees. How many? 2. Because we know that these are the minimum values only. For getting 4 rupees, will you use 5 rupee denomination to get 4 rupees? Definitely not. Which means that from these possible denominations, you will ignore 5, and now the problem reduces to using 0 1 2 denominations to get 4 rupee. Where is the answer to this present? The answer to this is present in the previous row and this particular cell. 2 coins. 2. What is the point? Now if I talk about 5, So you want 5 rupees. Do you think we can use 5 rupee to get 5? Yes, we can use. So I have one option. I can use only one coin to get 5. Or suppose if I'm ignoring this 5 rupee coin, how many do you think these denominations will be required to get 5 rupees? The answer to this is present in the previous cell, 3. So minimum of 3 and 1 is basically 1, which means 1 coin is now the minimum I will be requiring to fill 5. Similarly 6. So do you think we have, what is the possible denomination? Since I'm in this row, pointing to this indicates all the denominations from this you can use. So 0, 1, 2 and 5 can be used. So basically, can you pick 5 rupees? Yes, I can use a 5 rupee coin. Since I need 6 rupees, right? Since I need 6 rupees, I can use a 5 rupee coin. So I'll pick up and put a 5 rupee coin in the box. 1 5 rupee coin, okay, 1 5 rupee coin. Amount you are left with is 1. So now the answer to this is 0, 1 to 5. Use 0, 1 to 5 denominations to get rupees 1. How many minimum coins is required? The answer to this is present in this cell. 1 rupee coin required using all the denominations. 1. So you can do this task with 1 coin. You have already solved this particular problem. Plus right now we have picked 1 coin equal to 2. So basically 2 will be added here. Likewise, you will find that 5 plus 1 2 rupee coin will be giving 7, means 2 coins. For getting 8, you can take 1 5 rupee coin, 1 2 rupee coin and 1 1 rupee coin. 3. For picking 9, you can pick 1 5 rupee coin, 2 2 rupees coin plus, sorry, 2 2 rupees coins, right? This is also possible. 3. For getting amount 10, you can pick 2 5 rupees coin, 2. For getting amount 11, you will pick 2 5 rupees coin plus 1 1 rupee coin, which is equal to 3. And the value in this particular cell is the minimum number of coins required to get 11. You see, for every cell, we are using the values in this particular point, the minimum of this, right? For every cell, we are using the values present in the previous cell. You can see, right? If you are not considering 5, we are excluding 5, then we were considering, can the problem be solved in minimum coins by using these 3 coins, or can it be solved by picking up the coin? Which of them is giving minimum, right? So as I said you, at every instant of time, you have 2 options, either to include a coin or to exclude a coin, right? We have either 2 options, either we can include a coin or we can exclude a coin. For example, if we are pointing to this particular row, we know that the possible denominations are 0, 1, 2 and 5. So you have now, suppose talking about this particular problem, 5, you want amount 5 and possible denominations are this. So to get 5, what are the options? You can use these all denominations to get 5, or what you can do is, basically you say that I will not use these denominations. So basically you can reduce the problem to 0, 1, 2, you can only use this to get 5, or you will be using all this to get 5. So if I use all only 0, 1, 2 to get 5, I will not use the denomination 5. It indicates that your answer is present in which cell? The previous row. 3 coins. And if I use the 5 rupee coin to get 5, I will be using only 1 coin. Which is the minimum? The minimum is 1 rupee. Then you will be picking up that, right? So like this way, basically this is the approach of solving this particular problem. Now we shall code the particular problem and how it is actually working, right? So let us now quickly discuss how this particular problem is actually working. So in order to code this particular problem, we shall create an array. Now you see, we have already discussed, we are creating an array, 2-dimensional array of size n plus 1 into amount plus 1. You understood why we are doing so. Now what we are going to do is, we are going to run a loop from 0 I less than equal to n I plus plus. What does it mean? It means that top to bottom, we are traversing top to bottom. For every row now, we will traverse all the column. So 0 less than equal to basically amount. Now we will say I plus plus, right? So what is happening? We are saying for every row, we are traversing every column. That is what we are doing, isn't it? First we are in this row, and traversed all the columns. Then we moved on this row, then traversed all the columns. Means for each value of I, traverse all value of j. That is what we are doing. What did we do first? As soon as we started our journey, we saw that first of all that we are encountering is when j's value is 0. When j's value is 0, we know that it means that amount is 0. So you don't need any amount. Basically, what should be the value in that cells? The value in that cell should be 0. So we will just fill that condition. This is the base condition, that if j is equal to 0, it indicates that dp of I and j should be equal to 0. Got the point? Else if I is equal to 0, what does it indicate? If I is equal to 0, it indicates that you are in this particular row, right? If you are in this particular row, you know that if I is equal to 0, accept this condition, because this condition we are already dealing in this part. If I is equal to 0, then you know that you cannot produce any amount, means you need infinite of such amounts. So basically I'll say if I is equal to 0, then dp of I of j should be equal to what? Infinite. So we will just use a variable inf, and initially we will initialize it to some maximum value. Suppose I'm using a maximum value as integer inf is equal to 1, and suppose exponential is 6. Okay, now we are using this particular value. Now suppose else if dp of I comma j is equal to infinity, when will we write infinity? Because of for filling up these cells. Which cells? Just now we discussed. When I will be equal to 0, when we are in this row, we filled up all those things with infinity. Why? Because we know that you cannot generate any amount with 0 denomination, right? So we did this. What is the next thing? Next thing we came across is else if our denomination is high. Else if, you know, when we say that if the denomination that you are using, that is I, let us say if num of I minus 1. Now what is this? Cool. See, if num of I minus 1 is basically greater than the value that is j, what does it mean? It means that what will we doing? For example, take this particular case, this particular cell, right? I is pointing to this row. What is the value of this row? 0, 1, 2, 3. Okay, I is pointing to 3. So I is pointing to 3, which means what is the maximum denomination I can use? So 3 minus 1 is equal to 2. So num of 2 is what? Num of 2 is 5. Means if the maximum denomination that can be used, num of I minus 1, that is why I am writing num I minus 1. You remember why I am writing I minus 1? I minus 1 is used here basically because of this reason. Why I am writing here? Because I know this is pointing to 3. It indicates I can use the last denomination. Last denomination is basically at index 3 minus 1, that is 2. 5. So if this denomination, maximum allowable denomination is value is larger than the amount that I require. Now amount I require is 1 and the maximum allowable denomination is 5. If it is greater, then what we were doing? Remember very easily, we know we were at this position. So basically the allowable denominations were 0, 1, 2 and 5, right? So when we found that this value is greater than the amount that I need, amount is 1, I need 1 rupee. What do? We ignore taking this denomination. And now the problem restricts to using this denomination to get the value 1 that we need. Okay, how do we write this in the code? In the code you will write, if the maximum denomination is greater than j, then it simply indicates you have to basically ignore the problem, right? You have to basically ignore the denomination, right? So for that, what we have to do? The problem will be dp of I j is equal to. Now how did we fill this particular cell? How do you think we filled this particular cell? We basically pointed to the previous row, right? We just pointed to the previous row, means this particular row and that particular column, same column, and we got the result. So how was that present? So basically we'll say dp I of j is equal to dp of I minus 1, pointing to previous row. What the point? And in the same column. Cool. So this is what we are happening when we see that the denomination is larger. Another case will be when your denomination is not larger, right? When your denomination is not larger. So let us take an example for that. So suppose now I want to generate an amount of rupees 7. And I am in this particular row. So if I am in this particular row, I value is equal to 3, indicates point to the index 3 minus 1, which is equal to 2 of nums array. So this is a nums array, point to the index 2, which means this index. So what is the maximum allowable denomination? Is 5. And we know the maximum allowable denomination is not greater than 7, right? Because this condition will become false then. This condition will become false, right? Because num of I minus 1 is 5 and 5 greater than 7 is false, which means we can pick this 5 rupee coin. So if we can pick this 5 rupee coin, what should we do? We should say dp of I of j, we will fill the value of this cell. Now we know how do we fill the value of this particular cell? We will say, we will assume that we will find out the minimum number of minimum of the results. So first option is you will pick up the coin. So if you pick up the coin, I'll assume I have already picked up one coin, and the problem now reduces to what? dp of I, and this will be j minus num of I minus 1. Now remember, why am I doing so? Comma, comma. Okay, let us understand this first. So assuming I am in this row, if you are in this row, you know that the maximum denomination available is 0, 1, 2 and 5 you can take to get rupees 7. Now num of I minus 1 is pointing to what? Num of I minus 1 is basically pointing to num of I minus 1. Okay, num of I minus 1 is pointing to this value here, isn't it? 5. This one here, 5. So we know that this value is less than 7, which means you can pick this. So I'll assume that I have picked it. So if I pick it once, so I'll take one 5 rupee coin. Now the problem reduces to what? The problem reduces to using 0, 1, 2 and 5 to get 2 rupees. Right? So we have to update this, isn't it? We have to update the value of j. This is the value of j. So initially j was 7. Now j should be pointing to j minus the amount that you have picked. That is what I am doing. J minus the amount that you have picked. The amount that we have picked is num I minus 1. Right? So now again this will be a sub problem that is being called. So how will the answer to this be found out? The answer to this is present in, the answer to this particular cell is present in 0, 1, 2, 5 to get 2. Basically it means you are in this row, the amount you want is present in column 2. This one, 1. So this value is basically 1. Right? So what will be the answer to this value? 1. So 1 plus 1 is equal to how much? 2. Got the point? 1 plus 1 is equal to how much? 2. So either you have this option where you can solve this particular problem using 2 coins, or that is why I am using comma here, or what we can do, you can simply say dp of, just ignore that maximum denomination, right? So as we have already discussed, ignore, since you are in this row, so 0, 1, 2, 5 can be used to get rupees 7. So suppose I am not going to take this denomination, then my problem will be reduced to using 0, 1, 2 to get 7. So how will that be possible? So I'll just say dp of I minus 1 and say getting the same amount j, right? I want to get 7 rupees and I will be reducing the denomination. I will not using the largest denomination. Now what will be the answer to this? So the answer to this we have computed to be 2, comma, the answer to this is equal to nothing but present in the previous row. So previous row to get 7, how much? 4. What is the minimum of 2 and 4? The minimum of 2 and 4 is basically 2. So 2 will be filled here. Getting the point? That is the intuition behind using dynamic programming, and you can see that how this particular table is basically helping us to store the result of sub problems which can later be used, right, in the further process. So basically this way the dp value will be calculated, and as soon as we just terminate the loop, now we will be asking ourselves if the dp of n comma amount, which is nothing but pointing to the last cell, pointing to this cell. Okay, you see the dp of n comma amount is pointing to this cell, right, pointing to this cell. So if it is pointing to this cell, the value of this is the answer. So if this value is basically greater than, suppose, so I am using here 1e6, so I'll be using a lower amount than that. Suppose I'll be saying 1e5. So obviously if that particular value is initialized to 1e6, then it will be true, right? I'll be using a lower value here. So basically I'm declaring infinity as 1e6. So basically I need any value lower than that. So basically if my amount is greater than 1e5, then if any variable which is initialized to inf will be true, because 1e6 is greater than 1e5. Definitely if some value, if the value is 1e6 there, it will be true, and in that particular case, as per the problem statement, we have to return -1, right? We have to return, we just have to return -1. Else what should we do is we should return the value of dp of n comma amount. That's it. So this is how we know that the answer that will be returned is 3, right? So this way we can solve this particular problem. Let us now quickly execute the code. So I don't want to erase this because quite a hard work we have done here. You know, it seems cool, right? Let us see if the problem is working fine. Okay, if num I minus 1 greater than j. So num. Okay, it's nums. Okay, not num, it is nums. Compile. Again it is nums, not num. So let us see where is the value. Basically cell number 31, sorry, downwards. So it is nums. just changing the name. Okay, we need a semicolon at the end of this particular statement, so these silly mistakes always exist. Okay, so somewhere we're getting a segmentation fault. Let us see where is the issue. Alright, so I just erased the screen and see the problem was basically I'm using I here, right? So it should be basically J, right? And that was the issue. So let us just see whether everything works fine now. Again we have a segmentation fault. Where is the issue? Let me just find out the, again it should be J++, right? So I'm really afraid of this kind of silly mistakes because that spoils all your efforts. So yeah, you can see the output is correct, coming fine, because we want 11 rupees from these 3 coins. So I can just pick up 1 2 rupee, 1 rupee. So I'll get, sorry, what is the answer? Okay, you want 11 rupees from these 3 denominations. So basically I'll be picking up 2 5 rupees coin and 1 rupee coin. So total 3 coins will be required to get the result, and you can see the answer will be basically 3, right? So let us successfully submit the code. So considering the time complexity, so basically you can see we are creating a table and just traversing all the tables. So size of the table is basically nums plus 1 into amount plus 1, right? So basically it depends upon this. So time complexity is again, and I'll be saying nums into the amount, nums into amount. The space complexity also remains the same, right? So in this particular problem we have also used the same space complexity because the table size was depending upon the nums and amount only, right? So yeah, that's all from this particular side. I hope this video was helpful. In case of any doubt, please feel free to put your doubt in the comment section, and just like, share and subscribe. Yeah, the video was lengthy, but yes, my objective was to make this particular problem as clear as possible, and I hope the effort was worth of it. And yeah, that's all from my side. Thank you.